given triangle from smallest to largest. Numero uno. What angle is the smallest? N. Why?
Because it's across from the shortest side.
Very good. It's across from the shortest side. 16 is our smallest side, so angle N is the smallest angle. What's the next one?
L.
L. Very good. Angle L. And the biggest angle?
M.
Angle M. Okay? All right, number 2, we've got X's. What's the smallest angle?
I put D and F because they're congruent.
Very good. D and F are the same. Because remember, when you have the same side, okay, those two angles are going to be the same. We have an isosceles triangle here, okay? Whenever you have two sides that are the same, your base angles, which are D and F, are going to be the same. So angle D or angle F as the first one. And then what's the biggest angle? E. Very good. Okay? Angle E. Because 8x is bigger, so that angle E is going to be the biggest one. Okay? All right, in exercises 3 and 4, list the sides of the given triangle from shortest to longest. But it only gives us 2. How do we figure out the third? How do we figure out angle B?
Subtract it from 180.
Very good. Let's subtract the other 2 from 180. So let's take 180 minus 21 minus 87. What'd you guys get? Minus 21 minus 87. I got 72.
Oh, whoops. I did 87 plus 21 first, and then
Oh, you added 21 and then subtracted 87? Okay. Yeah, in that case, you would get 114. I think. Maybe not.
72.
I got 72. Can you try that again, Yelisa?
I got 72.
Oh, you did? Okay. Perfect. So this one's 72. So if that's the case, guys, what's our shortest side?
AB.
AB. Very good. Because it's across from the shortest angle, which is 21. What's the middle side? What's the second smallest side? AC.
CA.
Or CA. Very good. Okay. And what's the largest side? BC or CB. Very good. Okay? Because it's across from the largest angle. Guys, I cannot tell you how frustrated I was when a few of you guys, it said what is from shortest to longest, and you put it from longest to shortest. You did not get full credit for that. And also, some of you guys, it was asking for the sides from shortest to longest, and you guys put angles. No bueno. Okay? Number 4. Oof. How do we solve number 4?
Huh?
How do we solve number 4? Definitely can. We have 3 unknown angles, all in terms of x.
Make them all equal to 180.
Very good, Juliana. All we need to do is just write them all, add them all, and set it equal to 180. So let's do that. Let's do x plus 2x plus x minus 4 and set it all equal to 180 degrees. Very good, Juliana. Okay, now there are some things we can combine. What can we combine? Noah? All the x's. What do we get there? Very good. X plus 2x is 3x. You add another x, you get 4x minus 4 equals 180. What's next? Add 4 to the other side. We're going to get 4x equals 184. Last step. Divide by 4. Very nice, Noah. And when we divide by 4, we're going to get x equals, what is that? 184 divided by 4. 46. Okay, now all we have to do is plug this in for our x and then figure out which ones we've got. Well, this one's just x, so this is 46 degrees. What's angle P going to be? 92. Very good. You just take 2 and you multiply it by 46. And what if we took x minus 4? What are we going to get there at r? What's that? 42. Now, some of you guys are really, really smart, and you'd be like, well, Q is x, R is x minus 4, so R has to be smaller, right, than Q, and P has to be bigger than Q because it's 2 times whatever x is. So some of you guys would just be like, automatically, R is our smallest angle, Q is in the middle, and P is the biggest. I don't work like that. You guys could absolutely, okay? If you did that and figured it out, 100% you would get this right. I like to solve for x, that way I'm positive in what I'm doing, okay? So what's our smallest angle? It's R, so what's our smallest side?
QP.
Good, Teresa, QP. Next, middle side.
PR.
PR, awesome. Oops, PR. And the biggest side?
QR.
QR, awesome. So QP, PR, and QR. I was very, very happy with our knowledge on this, though. The majority of all my classes got these questions right. If you're still struggling on this, you need to do more practice, okay? So remember, whatever side is opposite the biggest angle, that's going to be your biggest side. Whatever side is opposite the shortest angle, that's going to be your smallest side. Okay, here we go. This is chapter 6, section 6. This is the last lesson of chapter 6. Inequalities in two triangles. You can find this on page 344 of your textbook. The Hinge Theorem. If two sides of one triangle are congruent to two sides of another triangle, and the included angle of the first triangle is larger than the included angle of the second, then the third side of the first triangle is longer than the third side of the second triangle. It's a very specific theorem. Okay, how I remember the Hinge theorem, guys, is I think of chopsticks, okay? Okay, I want you guys to write this down. So if we got chopsticks, draw like a small pile of rice, or like, yeah, I'm a terrible artist, but if you can draw better rice, draw like a small pile of rice, and then a bigger pile of rice, okay? Now, your chopsticks are fixed, right? So in order to pick up the small piece of rice, the angle that you're making is gonna be nice and small, okay? In order to pick up more rice, the angle that you make with the chopsticks has to be bigger, okay? And as long as the chopsticks don't change size, whatever you're picking up with your chopsticks is going to be related to that angle, okay? So a bigger angle would mean a bigger side. Smaller angle would mean a smaller side. Bigger angle means more rice. Smaller angle means less rice, okay? That's how I remember the Hinge theorem, is by thinking about chopsticks. Now, what the Hinge theorem says in math terms is that if we've got AB is the same as DE over here on the left, okay? They're the same size. And the same thing with AC and DF. So between these two triangles, if angle A is greater than angle D, then the side opposite angle A, which would be BC, is going to be bigger than the side opposite angle D, which is EF. Vamos. The converse of the Hinge theorem. Okay, so if two sides of one triangle are congruent to two sides of another triangle, and the third side of the first triangle is longer than the third side of the second, then the included angle of the first is larger than the included angle of the second. So it's the exact same theorem, just in reverse. So it's the converse, okay? So when you're given the angles, that's the regular Hinge theorem. When you're given the side, that the side is bigger than the other one, and you conclude that the angles are bigger, that's your converse, okay? So your converse is when you're given the side and you conclude that the angles are bigger. Moving on to example 1, is we need to know that two of the sides are congruent. Example 1, given D is the midpoint of AC, angle 1 is less than angle 2, what can you deduce? All right, well, if D is the midpoint, it already filled this in for us, but remember, a midpoint divides any line segment into two equal parts, so that's why D being right here divides AD into an equal part as DC, okay? Again, this one is not drawn to scale. It definitely looks like DC is a little bit bigger, but we're gonna take the word problem's word for it, okay? What can you deduce? All right, well, we know that angle 1, the measure of angle 1 is also greater than the measure of angle 2. There's one piece of information about these two triangles that's not given to us, but we can see it from the diagram. What do you guys think? Because remember, for our Hinge theorem, do we see another side that's congruent?
Side BD and BC.
So I heard BC and BD. Not necessarily.
I said AD and DC.
AB and BC. Nope.
I said AD and DC.
AB and DC. Nope.
I said AD.
And DC.
Yeah,
Yeah, we already knew that one. We need a second side between the two triangles.
BC.
Nope.
BD?
Ah, BD. Is that a shared side?
Yeah.
So isn't it congruent to both triangles? Okay, so we've just proven that we have a pair of congruent sides. AD is congruent to DC from our first triangle to our second triangle, and also DB is congruent to itself because it's a shared triangle. We know that the measure of angle 1 is greater than the measure of angle 2. Oh, I'm sorry, is less than the measure of angle 2. Erase that. And put less than. Oh, did I put greater than over here too? Okay, guys, erase over on the right as well. Sorry. It should be that measure of angle 1 should be less than the measure of angle 2. So our conclusion here, guys, is that BC must be less than AB. By the Hinge theorem. This is our conclusion. Okay? So what we're saying is that BC, that side opposite angle 1, is less than the side opposite angle 2, which is AB. Complete with greater, less than, greater than, or equal to. Angle 1 is going to be compared to angle 2. All right, well, this is going to be the converse Hinge theorem because our conclusion needs to be about an angle, okay? Let's put congruence marks on all of the congruent sides. This 4 side is going to be congruent to this one, which will also be congruent to this one, okay? What else is congruent?
The line in the middle.
Very good. The line down the middle is shared by both triangles, so that one's going to be congruent to itself. Okay? So we've got 2 congruent sides and 2 angles that we don't know about. But we're given the length of the sides across from those angles. Do you think angle 1 is going to be bigger or smaller than angle 2?
Bigger.
Bigger. Why, Marcos?
Because the side of angle 2 isn't as big as the side of angle 1.
Very good. The side associated with angle 1 across from angle 1 is bigger than the side across from angle 2. So just write down here, just put that angle 1 is opposite side with length 4, and angle 2 is opposite side with length 3. Okay? So we were given 2 sides that were congruent. The shared side and that side of 4 that both of the angles include. Okay? So then we looked opposite. Okay, well, the 4 is bigger than the 3. So therefore, angle 1 must be bigger than angle 2. This was the converse Hinge theorem. Okay, you see how we were given the side and we were determining our conclusion was about the angles? That's the converse. When you're given the angles and concluding about the sides, that is your regular Hinge theorem. Okay. Guys, example 3. Okay. Find the range of values for k. Okay? 5k minus 12 is that angle inside. Then we've got another angle of 38. We've got PL is congruent to LM. And then we've got two sides that were given on the opposite side of those angles. Okay? Well, first off, in order to apply the Hinge theorem, we need to prove two sets of congruent sides. I see PL is congruent to LM. It's the same for each example we've done. What's the other set of congruent sides?
PN and MP?
Those are 18 and 19.
Oh, LN.
LN, very good. It's the same, it's a shared side, so it's always going to be congruent to itself. So LN is congruent to LN. Awesome. So we've got two congruent sides. Do we know anything about the angles? Not really, because that's in terms of K, all right? But do we know anything about the sides? Yes. We know that MN is bigger than PN because 19 is greater than 18. Okay? So if MN is bigger than PN, what does that tell us about the angles PLN and NLP?
They're not equal.
They're not equal, but we know something even more specific. We can write an inequality. So angle PLN, we're comparing to angle NLM. Which one needs to be bigger?
NLM.
Why?
Because
You're right, but why?
NM is bigger than PN.
Very good. The side across from it, do you see how this 19, this 19 is bigger than this 18? So then that angle, that 38, must be bigger than the 5k minus 12.
Because of the Hinge theorem.
Very good. This is the regular Hinge theorem. Okay? And it wants us to solve this inequality so that we can figure out all of the values for k. We're going to treat this like a regular equation. I know we haven't really done inequalities in here all that much. You just treat it like a regular equation. The only time you change anything in an inequality is when you divide or multiply by a negative number. Okay? So in order to solve this, we would just add 12 to both sides. What we're going to get is 5k is less than 50. And then we're just going to divide by 5. Since we didn't divide by a negative number, our inequality stays the same. We're going to get k is less than 10. So k has to be less than 10. Sometimes, guys, it helps. Once you have your 3 pieces of information, if you draw a line, okay? So my 3 pieces of information were the 2 congruent sides, the fact that MN was bigger than PN, and then I finally, after those 3 pieces of information are in there, I can form a conclusion. My conclusion was that one of the angles needed to be bigger than the other angle, okay? We needed 38 to be bigger than 5k minus 12. And then we just solve.
Wait, so now that we're done, do we still do this?
Yes.